So now we have Richard Nakamura, who's going to tell us more, and this time on testing of two application ranking approaches at the NIH Center for Scientific Review. Thank you.
Thank you very much. I appreciate the invitation to come and even the pressure Drummond put on me to make an appearance. I wanted to tell you about a couple of intervention experiments that we have done to try and see what a change in our scoring process, what effect a change in our scoring process would have on our ability to rank applications. I'd also like to say about conflicts, though nominally I don't have any conflicts, I am employed by the federal government, and that probably influences my perspective. Now, quickly, for the current system, which you've heard part of, I won't repeat all of these things, but applications are assigned to 3 reviewers who provide preliminary impact scores using the whole digits 1 through 9. And they provide critiques. After a panel discussion of each of the top 50% of applications, all panel members vote on a final overall impact score. Each application's scores are derived from the average of all panel members' votes and multiplied by 10, resulting in final scores of 10 through 90. R01 applications, the R01 is the basic grant application for NIH, are assigned a percentile based on the scores of applications reviewed. Now, this is the distribution in 2016 of our R01 grant application scores across 3 review cycles. The overall number of scores is over 32,000, so we have a pretty high level of accuracy here. And you can see that this is a skewed distribution, and in which of the discussed applications, so the scores are naturally skewed towards the good end, 10 being the best score, 90 being the worst. The interesting thing about this is that the scores are of 10, 20, 30, 40, and 50 have very clear peaks, with the absolute score of 20 being 4 times as high as the scores for 19 and 20, or the related next door scores. So this shows a problem of both grade inflation and grade confusion at these 10, 20, 30, 40 levels. So we're looking for an approach which would help differentiate grant applications further, and we tried 2 different approaches. So one, we tried a rank order approach, and the potential advantage is reviewers are not forced to give applications higher or worse overall impact scores than they think the applications deserve. They also, reviewers are required to distinguish between applications of similar quality and separate the very best from the rest. And reviewers have the opportunity to re-rank applications after hearing the discussions of all applications, something which we can't do in the current system. Some disadvantages are that applications cannot be ranked with respect to applications in the previous 2 rounds, as is done in the percentile system. And reviewers in study sections that cover highly diverse scientific areas may find direct ranking more difficult. Also, if at the end of scoring they do private ranking in the 1 through 10, 1 through 10 ranking, that may lack the transparency of the current system, in which reviewers who vote out of order, out of the range set by the assigned reviewers, must provide a justification during or after the discussion. So there's more transparency about how each of the reviewers are voting on each application in the current system. That could be covered up in a ranking system. So we decided to do a pilot study in which a ranking was tested against the current system. So it's carried out in parallel with the current system in 2014 and 15 council rounds. Applications were scored as usual, and reviewers were asked privately to rank their top 10 R01 applications in order. And ranked data was analyzed for informational purposes and not used for funding decisions in this case. So we had a lot of discussion, and I'm open to suggestions on how we can better display the data. This is to simply show the proportionate scoring compared to the percentile bins of a given application. So the ranks are on the left, and the percentile bin is at the bottom, with about 70% of the votes for rank of 1 held within the 0 to 5th percentile. You can see that there's quite a good consensus around the first 2 or 3 ranks, as there is with the current percentile system. But as you move up the ranks, there is a much less agreement about what is the best application within a group. Just to make it a little bit easier to see this, you can see this in percents. So 70% of the vote for the first best application was within the top 5 percentile points. And then this goes down to, at the 10th rank, about 18% of the votes were in the 15th to 20th percentiles. This will be a score good enough for funding in some institutes and clearly not in others. What about doing it in another way? And this was suggested by a number of reviewers about adding a half point for scoring, and the reviewers were asked for more scoring flexibility than 1 through 9, and asked that they have available an extra half point. The ability for reviewers to score application with half-point increments may spread scores and allow reviewers to score more precisely to reflect their opinion. However, if we simply allowed the original scoring based on additional half-point increments, we already know that the scoring would again be re-squeezed into the lower quarter of the voting segment. And so we did this in the final vote. All reviewers were allowed to be within the range of the original scorers or reviewers, but they could freely, without declaring it, add or subtract a half point. So that's what we tried, and this was the result. Essentially, what happened is there was a considerable decline at the absolute scores from 10, 20, 30, 40, so that at 20, rather than 4 times as high for the score of 20, it's about double the height of the 19 and 20. And then at 30 and 40, there's a very tiny increment over the general range of other related scores. These curves relate to slightly more than 700 reviewers across about 15 study sections. So this does not, it's a much noisier curve than the others. I'm sorry, 39 study sections. How did reviewers feel about this? I should have used the green and red system that we used in our other cases, but the orange and blue sections are the agree and slightly, very much agree and agree, pink being slightly agree. And you can see that the quality of the prioritization, a majority of the reviewers thought was positive, and but not as strong as the original face-to-face kinds of evaluations. Scoring accuracy, they thought was better, closer to 70% agreed. Reviewers are conservative. They generally don't like to change systems. What was striking here is that in this case, they called for a change in policy to allow them to more systematically use this score. And we are planning on doing more testing of this to see whether or not we should change our policy. That's it.
Great. Do we have any questions? Looks like there might be one coming. Good.
Well, let me just say I'd really appreciate having any discussions later here with any of you who would like to discuss NIH grant policy and peer review and any ideas that you have about how we should think about changing peer review. Thanks very much.
Thank you. Well, actually, I think we have a question, so do stay at the podium, because there's one here. I was going to say, you've opened the floodgates now. No, here we go.
Well, bravo for doing the study. This is great to actually see different scoring systems tested side by side, because the big problem is if we have no gold standard, which is very hard, so we're comparing two systems and we don't know which is better. So one idea is to include grant applications and seed them with, well, insert deliberate mistakes. Make some grant applications deliberately bad. Put them into your round and see if the reviewers can actually spot them. Then you do have some kind of gold standard mixed in there.
Yes. We are, this is a little bit like a reliability check, and we are, within the anonymization study that we're planning, we will end up getting at least 6 independent reviews of full grant applications, as well as anonymized versions of those applications to see whether or not factors like race, ethnicity, geographic region, other factors, seniority, affect the outcome in scores, gender as well.
Could I just ask what sort of error you were thinking of? Because, in fact, Fee Godley and others at the BMJ did a study by inserting errors into papers to see if peer reviewers pick them up. But then you've got results, you've got study results, and there's scope for having errors. But with a grant application, you've got study methods. So I wonder what kind of error that you would think of inserting, just briefly.
Wrong cell line, terrible sample size calculation, not citing the literature properly, a study that's already been done.
You're expecting a lot from the reviewers, I suspect. If you think they're going to spot things like that. But anyway, I'm really intrigued. Thank you. Food for thought for all of us, I'm sure. Thank you. Yeah.
Hey, Scott Lemire from Baylor College of Medicine. The currently early stage investigators and new investigators get a bit of a bump in their overall impact score. What was sort of the plan for managing that in the rank system? Would there be an automatic move up in rank, and if so, how many points? What was sort of the translation going to be for the ESIs and the new investigators?
Though we cluster those, we don't actually call for a difference in scoring. We just call for them, reviewers to take into account difference in seniority. We have not planned on making any change. What the institutes are doing is actually funding a higher proportion of those so that the success rate of those individuals is equivalent to that of more senior investigators. So the actual compensation occurs at the institute level at the award stage.
Thank you. And there's one last question there, I think.
So, Brooks Hanson, to you. I'm wondering if you're in trying to quantify what is inherently partly subjective process and driven by systematics in who's selected to review, perceptions, and so forth, that the noise, the inherent noise is larger, which is the fine distinction between fairly good grants that are on the bubble, is well beyond any kind of signal quantifying point system, whether it's a 5-point scale or a 20-point scale or a 1,000-point scale.
Certainly, I would agree that the system is very noisy, especially when you have 3 primary reviewers. We are looking at the potential for systems that would produce higher numbers of reviewers. The current system for funding applications makes that difficult, but we have thoughts about possible solutions. I won't go into it right now, but
you have a couple of minutes if you'd like to.
So one of the things that NSF has been doing is applicant reviewers. So they've tried to see whether or not they could do in a fair way having applicants of a round be the reviewers of that round. If we gave such applicants, if we could solve the conflict problems and gaming problems, those applicants would have the right expertise within clusters, and a reasonable workload would be 7 to 10 applications. That means that each application could get 7 to 10 reviews. I think that would give us a lot of information about reliability, about how to look at scoring, and I think this is an interesting idea that we should try.
Okay, thank you. And there is one more question. In fact, we have a minute
Misha
or two.
Teplitsky from Harvard. I've seen a little bit of work suggesting that ranking versus rating tends to favor different kinds of applications around innovativeness. I wonder if you've seen anything about, if you see a different kind of application getting selected.
So the same applications are selected for the top 3 or 4 positions. After that, it gets very different across reviewers. So, and we even see things that were originally scored 60th, 70th percentile suddenly coming up in rank. So it's created a lot of information that we don't quite know what to deal with. So if any of you have suggestions or ideas that you'd like to discuss, come and see me.
Okay, thanks very much.